Welcome back to our podcast, Let's Talk About Labor. This podcast aims to help farmers and ag businesses connect with other ag businesses in Tennessee and other surrounding states, specifically to hear and learn about their experiences and challenges related to labor and the strategies they have used to overcome these challenges. We talk about various topics such as U.S. temporary foreign visa programs, mechanization and automation, and worker recruitment and retention strategies, among other topics. Different agencies and organizations have partnered with us to make this podcast possible, including the Southern Risk Management Education Center, Gap Connections, the U.S. Department of Agriculture SCRI program, and the Tennessee Department of Labor and Workforce Development. This podcast will not be possible without the participation of farmers and ag businesses. My name is Margarita Velandia. I am a professor in the Department of Agricultural and Resource Economics at the University of Tennessee. Amy?
My name is Amy Fulcher, and I'm a professor in the Department of Plant Sciences at the University of Tennessee.
Alicia?
My name is Alicia Reen, and I'm an assistant professor in the Department of Agricultural and Resource Economics at the University of Tennessee.
Okay, we would like to introduce our guest, Terry Hines, who also was with us in the previous episode. He is the owner of Hale and Hines Nursery in McMinnville, Tennessee. Welcome back, Terry, and thank you for taking the time to talk to us today.
Thank you for the invitation.
All right. In our last episode, we talked with Terry about the labor challenges he has faced in his operation and the strategies he has used to overcome these challenges. In this episode, we will talk specifically about his experience using mechanization to address labor challenges in his operation. Amy.
Terry, you've used many mechanical aids to address labor challenges and make production processes more efficient. Therefore, we want to ask you a couple of questions about your experience with these mechanical aids. First, we'd like to ask you about your decision-making process adopting 3 mechanical aids in your operation. Can you tell us about your experience, including how you identified the need, discovered or thought about the specific mechanical aid, and your thought process from before you adopted it to when you decided to buy or develop it, evaluating the advantages over your current system or process, impact on workers, challenges, and costs?
Okay. Labor's always an important cost doing business in any business, and agriculture has been pretty, I would say, lagging in adapting technology. I know it's coming more and more, but years ago when the people that did irrigate would set up aluminum pipe through the field and run aluminum pipe with sprinklers on it, and then move that aluminum pipe and then run it again, and so now it's hard hose machines, or it's fixed in place irrigation like we use in our container operation. But it's just, there's better ways to do things. And so many times when I see a need, I try to look at how we do what we're doing and any given task, and just I try to imagine, how could we do this faster, less lifting, a smoother operation to get something done, whether it's a potting crew, whether it's a spray crew, whether it's a loading crew. Just anything we see that we can use any mechanical means, we want to do that because we want to make the guys' jobs as easy as possible. And we want to have as few of injuries as possible because it's a physical job, working with trees and moving trees around, loading, unloading, stacking, shifting. All that requires physical labor. So if we can make that easier on the employees, that's a big factor. And then if we can do something cheaper, because we know if a machine can do it, if you can run a motor to do something instead of a man doing it, that's a better option. And the mechanical means are less apt to break down or to get hurt, for sure. So I think that's really important. But I think what I try to do when I see what we're doing, for one thing, I see what other people are doing. With the internet, you can access a lot of information there. You can adapt, and you can adopt practices, and then you can kind of massage those, tweak those to fit your individual needs. I'll give you an example. We grow our boxwoods in the field primarily, and we grow them on a 3.5-foot space row. Well, that's too narrow to take a skid steer loader in and dig with a mechanical spade. You can't get between those rows. So, we looked at other options. There's some little miniature scoop diggers that they sort of vibrate, and it's like an ice cream scoop. And talked to some people that had them. They said, well, they really liked them, but they sort of self-destructed because there's so much vibration. So I thought, well, that's not a good option. And they're expensive. They're $60,000 or something for one of these little machines. They're all made in Europe. So then conventional tree spades, which is what we use to dig all of our field stock, is just a hydraulic spade that goes on a skid steer loader. Well, I thought, well, I need to figure out a way to get that small spade in the middle of that block. And so I was talking to my son-in-law, who's very mechanical, and I was telling him, I said, what I'd like to do is to take a mini excavator and put it up in the air so we could go over the top of the trees and then reach the different blocks and dig with these small spades, instead of, because we were having to do those by hand. We'd have to hand dig things, and it just took a lot of labor, and nobody really wanted to do it. It's just hard work. So he said, oh, they have something like that. I've seen that on to unload train cars. Well, they take a big excavator and they put it up on stilts and still put the tracks on the ground, and they drive a coal car underneath it, or a grain car, and then they can unload that car with that excavator. So, excavator's like a big backhoe with tracks, for those of you that are not familiar with excavators. But anyway, so I was able to, on the internet, find 2 or 3 different companies that made these gigantic machines. And from that, we were able to just scale down and make a small version of that. And we took about a 12,000-pound excavator and raised it up 4 feet in the air, made it where the tracks would go in and out so it could adjust for the width of the boxwoods. And so we're digging all of our plants we can't get to with that machine now. And we adapted something from another industry, but made it work for us. And so that's just one kind of a good example of adapting something. A lot of times it's really a very simple fix, like we would have somebody standing there with a garden hose watering in. Once we potted a pallet or a trailer load of trees, one man just stood there with a garden hose and watered that in. So that's one guy standing all day holding a garden hose, and it's not a good use of labor. So we looked at what some other people were doing, and we designed and built, we call it like a water tower, that you actually drive the tractor through, pulling 2 trailers behind you. You punch a button, and it starts, solenoids open up, and it just floods the trailers with water. It's like a gigantic waterfall from both sides. And then they just drive slowly through there. So it waters it. It doesn't take any labor other than the tractor driver stopping and punching a button. And we're able to do the same thing to water all the plants in. And then that lets that guy that would have been holding a garden hose do something more productive. So that's another simple example. But we've done a lot of different things, and I'm not sure if you want me to list other things, but I mean, some things are really simple. It's like we use a pallet system when we're loading and unloading our trees, shipping our trees, instead of having trailers that we put all of our container trees on and go to the dock and unload those. We just, in the field, we tie the tops up, get them ready to ship. Then we load them on a trailer that is more or less just a rack that holds two big pallets, custom pallets that we build. And then once they get to the dock, we use forklifts just to take those pallets, set them on the dock. When we load the truck, we pick that pallet back up with a forklift, drive it in the truck, and stack the truck with that. So we try to cut out how many times we touch a plant. The less you touch it, the less you move it, the better it is on everybody. So that's another way that we that we just see, things like forklifts are tremendous tools. There's a lot of tools that we start doing things one way and then we say, hey, there's a better machine to do that. So, being a field grower, we had skid steer loaders that we did everything with pallet forks and buckets to put our mix in. And so there's, wheel loaders are much better than skid steers to load material in a soil mixer, and forklifts, even though it takes a big concrete pad, forklifts are the best way to load material, pretty much, hands down. They've been around a long time, but it's just a good way to do it. So, and sometimes we see some other people using same machines. Sometimes we just have to kind of think about how we could do this and invent it.
Terry, I have a little bit of a follow-up on what you said. When you think about cost, for example, that mechanical aid that you had to customize, that you basically had to adopt from another industry and adopt it to what you were doing it, like you basically already have, it seems like you have a vision of where are you have labor that could be used more efficiently somewhere else, right? That's one thing. And second, uh, are you thinking about, you already told me that you were thinking about this technology that was $60,000. It's expensive, but it was not working, it was breaking. So
Mm-hmm.
when you customize that, do you have to contact the company and then work with them to try to customize it, or you do in-house customization? And then the cost process, when you think about these technologies, you think this is how much it costs, you automatically think about that return on investment. How, tell me a little bit about your thought process on the cost.
Sure. That I'm not an engineer, but we do a lot of sort of in-house engineering and design. And like I said, we have a really good fab guy. So that was a project we did in December and January when things were really slow, and I was able to kind of be there hands-on with the guy. And we size things. We get things from steel suppliers. We have parts cut, and then we fab them up, weld them together. But I didn't really. I mean, I have a grandson that's going to have a mechanical engineering degree, and it'll be great to have a true engineer that can draw stuff on a computer. But a lot of stuff, what I do, I sketch it out, I scale it out, and make scale drawings to do things. And since we build a lot of our own infrastructure, irrigation, shipping facilities, I built a bridge over a creek that divided our farms, things like that. I learn a little bit about what we're doing before we try to do something like that. And sometimes I might call an engineer and say, hey, I'm gonna build this bridge. Have you got anything comparable? And he said, yeah, I've got a 75-foot bridge we did. And I said, well, I'd like to purchase the plans for that or something. People are usually really willing to help you if you just tell them, I really need some help, to figure this out. So that works really good. A good example of cost savings is a lot of the nursery, or some of the nurseries in the United States, are using some automated trimming machines, and they're mostly made in the Netherlands and in Italy. And I looked at some that were being used. I thought, yeah, that's a good fit. It was probably a $50,000 or $60,000 machine when I bought it, but I did a cost study to see about how much does it cost me to trim 5,000 boxwoods. So how much labor it took, this many hours, and it came up to 35 cents a piece, or I don't remember what it was, but I put a pencil to that. And then I think if we got one man doing that same job in the same amount of time with a machine, we can eliminate 4 men doing that job, and they can be doing something else that a machine can't do. So I do try to run cost analysis of, this is what it costs to do it currently. If we change, this is what it would cost to do it with a machine. So reducing labor is a big thing.
Mm-hmm.
And there's plenty of other, potential areas to reduce labor. And I did fund kind of a research program with some graduate students at Carnegie Mellon to develop an autonomous robot, you say, but a wheeled vehicle to go through the field and with a shielded sprayer and spray between the rows of smaller pots. Because we spray those, we have a machine we run with like a wheel on it that the guy has to walk behind. And they did get a good prototype. We haven't taken it, further than that, but they did get a good prototype that would just go down the road, turn around, come back down the next road, turn around. And these were 5 Carnegie Mellon students that did it as a graduate project. And so they came to the farm various times. We've got a lot of good information from that. And I think eventually we'll be able to automate that. I did hear of some nurseries that are starting to use some automated tractors. There are some different companies making some. They use them a lot in the orchard industry, but making some GPS directed tractors or cart pullers or whatever to eliminate some people doing that. So I think there's a whole lot of innovation that still to be done in what we do.
Excellent, Terry. And we're going to transition to Alicia asking you about other mechanical aids. But one thing I want to emphasize is exactly what you said. You said eliminate labor, but indeed, you actually talk about reallocating labor more
Yes,
efficiently, right? I really
yes.
like the way you worded there. But I'm going to go ahead and transition to Alicia.
All right. So you have talked to us about the mechanical aids that have worked for you. However, we would also like to learn about those mechanical aids or mechanization strategies that you adopted but chose to discontinue. Could you walk us through your thought process for why you decided to adopt them and why you decided to discontinue their use?
Sure. One, just to give you, there's more than one example, but we tried a tree tire that would go on a loader that you could, it had bales of, I guess, hay baler twine, and it would circle around a tree. You'd start at the bottom and go up to the top, and it would tie the tree up as it went. And it was slow, and it was much quicker to do it, or as quick to do it with a man just manually laying the tree down and tying it up. So, we scrapped that. We tried 2 different vibrators on our potting line that would vibrate settle the soil around the plant. Like if we shifted from a 15 gallon to a 30 gallon, it would sit on this vibrating table and it would supposedly compact that, vibrate that. Well, it never got tight enough where we were happy with it. So instead, we still have to do that manually, and the guys just pack it in there manually actually with a sledgehammer. They sit there and pound it with a sledgehammer all day, but they do it just wasn't up to our standards, and the plant was too loose, and we tried some pretty expensive machines to do that, 2 different manufacturers. That didn't work. At one time when we were doing all field grown material, we used the Tree Boss, which is a kind of a robotic grapple that's controlled by the man on the skid steer that'll pick up to 1,000+ pound ball, pick it up, put it on a truck, pick it up from the field, put it on trailers to bring to the yard. They worked really well, but you had to really micromanage them. It was something that, you had to have designated people that really learned it, and they just stayed on them all the time. Where now we've just grown and we do so much more material. Instead of using those, we use like a pot fork that adjusts in and out, that they can pick up 3 or 4 trees at a time, and it goes quicker because they're just doing it with a machine that picks up a little bit more. Even though it takes more labor, you got to have a guy on the truck to take them off. So you add a guy, but that's one thing that I think it's still a good machine in some instances, and we still have 3 of them that we don't use anymore, but maybe we'll adapt them for something else. Another thing we did, and this is one that I'm not giving up on yet, but we mounted a small hydraulic crane on the back of a tractor, and the idea, and then we developed 2 or 3 prototypes of a grapple. When we do pot in pot, there's one pot in the ground, and then there's another pot that's got the tree in it with the potting soil that slides into that pot, that socket pot. Well, there's only about 1.5 inches that's sticking above the pot that's in the ground. So it's tricky to grab that pot on the top and pull it out. Now the crane worked fine. We could pick up, large trees, pick them up, but getting the grapple situated where it would grab onto just that top pot and pull it out. And, we got it working, but it took one man to stand there and make sure it got the pot just exactly right. And we did, like I said, we did 3 different prototypes. We tried, spikes going into the soil to pick it up. That didn't work. And we tried, hooks that locked when you went down. That didn't work. And so we tried we tried it 3 different ways, and we never could get it where it really worked. We still use that little tractor with the crane for a bunch of things because the crane's handy, but it's not what we initially planned for it. And so we're still working on that. I think eventually, Amy, they might be working on some things to remove a pot from the ground. So then maybe they'll come up with something that just works really good, and we'll just do one of those. But
That's right. Yeah,
but yeah.
all of Terry's innovation and trial and error and prototypes and then the need that he knew really were the inspiration behind one of our 4 pieces of automation in the LEAP project. And so we will get to see more development in the pot harvesting space over the next 5 years.
Mm-hmm. Yeah, which would be great because that saves guys, pulling a big pot out of the ground. So if you had somebody could run through there with some type of machine, set them on the ground, ideally you would pick it up one time and set it on the pallet and it would go to the dock. But in practicality, you have to tie the top and get it ready to ship. So we have to do that in 2 stages. We have to pull the pots, then come back, tie the tops, then load them onto the trailer. So there again, I've had some other ideas about, rollers down to the middle of the trailer to make it easier to, once you get them on there, slide it to the end and things like that. And some ideas about a slide when we're putting them in the socket pot to slide it off the back so they don't have to manually pick that pot up and put it in a socket pot. So there's like I said, there's plenty of room for innovation and creativity, and anyway, or copying somebody else that's smarter than I am. So.
Well, Terry, you're right on not giving up, right? Maybe we can do another podcast at the end of the 5 years and see where we're at, right?
Yes.
So we're almost at the end of the episode, and I want to end the episode asking you maybe to pick, I wanted to make it more specific. Pick 1 or 2 mechanical aids. Let's just think you're talking to a nursery operation that is not very mechanized, is still in the infancy of thinking about mechanization. Think about those 1, 2, or 3 pieces or mechanical aids you think are the most effective, that are easy to adopt, things that
Mm-hmm.
will definitely help labor on the end. And also thinking about the future, those things that are not available at the market yet, but that you
Mm-hmm.
think will be a game changer for the nursery industry in the future.
Sure. I think one of the biggest innovations that we use, and this is something that is available now, are automation with our irrigation system. We have a lot of containers that we water every day, 4 to 6 times per day, and we do all that with a computer operated controller. It's connected to the internet, so you can go on your smartphone, you can turn a zone on, you can troubleshoot, you can stop it if it's raining. You could do rain sensors, which we don't do. We like to do that manually. But automated irrigation, and our system is, we do about 400 zones. So each zone is like a 2-inch line. And so we do about 400 blocks of trees that are controlled by a 2-inch solenoid. So, and some people still go out there and turn a valve on to run their irrigation. To me, there's no way we could do the production we do by doing that. You'd have to have multiple people turning valves on and off, and you couldn't do pulse watering, which is a whole nother thing that we try to do to save water. There's a lot of things you couldn't do without the automation we have. So that's a really good one. A simple one in our potting line, and this is another example, but once we got the tree potted, 2 guys would pick that, say, 30-gallon tree up, and they would set it up on the trailer to take it to the field. Well, that's not a good use of labor, and it's a hard job. So just the simple thing as a conveyor that you put on an incline. The Egyptians knew about these incline planes, I think, and so we adapted that from those guys. And so we just push it on the bottom of that incline conveyor, and it takes it up level with the potting trailer, and then the guys just real easy because we have metal pallets just slides it over there. One guy can just slide it right in place. So something as simple as a conveyor. We use roller conveyors for some of the bigger stuff while it's on the ground, while we're moving it through the potting line. We use a mechanical, I guess you call it a mechanical root pruner that we designed. We saw one that someone else built, and we designed our own to suit us. We didn't like what they had designed exactly, but it works really good. It, instead of 2 or 3 guys with machetes chopping the roots to get them ready to, because we root pruned extensively when we shift, this thing just drops in a hole. There's 3 big saws that cut it. It gets cut 6 or 8 times, and then it pushes on down the line. And there again, it's a conveyor bringing it to that point, conveyor taking it to the potting machine, rollers taking it back, another conveyor taking it up to the trailer. So just really simple conveying equipment works really good. That's some things we do. And I've already mentioned, instead of skid steers, use forklifts. Instead of skid steers, use wheel loaders, things that work better for a given job. I think in the future, the robotics, automated tractors, sprayers for sure, inventory. The Carnegie Mellon students have taken some of the technology they developed here, and they're actually using the LiDAR and some of that to do some inventorying and working in the industry. I think they're beginning to help some of the growers, especially the big growers in Oregon that have tens of thousands or hundreds of thousands of trees that they need a size and a count on. So inventory with all the sensor technologies, that are coming out and getting cheaper. I think it's very, we're going to see a lot of that in the future. I think drones are really important. I know they're being used for spray, for disease. It's a little hard with what we do because we have so many different kinds of trees, but monocrops, they're already using them big time for, reading stress, reading wet points, in monocrops like soybeans, corn, wheat, things like that. They're already making good use of the drones. It would be nice to be able to fly over, the whole farm and say, hey, there's a problem here. You got an irrigation problem. You got, you need something. There's a bug problem. But that, just for scouting. And we also do use them for mapping. I think RFID scanners are a great inventory control thing that probably are coming, or something like that, for shipping and keeping up with inventory. The problem with growing trees is they grow fast, especially in a container, and they're always changing sizes. So there's a certain amount of legwork right now that we do that can't be done with a drone. But anyway, that's just some of the things I see in the future. I think there's still just tremendous amounts of improvements that can be made, and efficiencies, and then using your a sparse resource, which is labor, to the very best effect. Maybe in 20 years we'll have robots that'll do a lot of the things that men do, and men will do the things the robots can't do.
Yep.
So.
This is very interesting information, Terry. You got us a little window in the future, right? And gave us a couple of ideas that probably, as Amy said, we're already working on some of those.
Mm-hmm.
But again, thank you for taking the time to talk to us. And I guess I'll see you in the next episode. Thank you, Terry.
Thank you so much. Bye-bye.